Every day, consumers around the world purchase a variety of products. These goods range from standardized commodities such as gasoline and motor oil, all the way to items which are made to order, like eyeglasses and many services. In order to create a high-quality product while being efficient and cost-effective, any company must select a manufacturing process that best matches the product. As a rule, the product being created determines the appropriate process. Process selection is based on two considerations. The first consideration is variety, or how much the product changes from customer to customer. Gasoline is a very standardized product. Although there may be a small variety between different blends, within each blend the product remains consistent. Eyeglasses, on the other hand, must be custom-made for every individual user. The second consideration is volume of demand. There is a large and constant need for gasoline, so operators refine and distribute it as quickly as possible. Glasses are custom-made to order, matching a prescription, and cannot be made in advance. A third consideration, the flexibility of the equipment used to create the product, is determined by the product being created and is often determined by the first two. These two main factors, variety and volume, may be seen as the vertical and horizontal axes of a graph. The result is called the product-process matrix. The most efficient production or manufacturing processes are found along the diagonal points on the graph. When a very standardized product is needed in very large volumes, a continuous process is the best manufacturing choice. This process uses highly specialized equipment with very little flexibility and is almost completely automated. Gasoline manufacturer BP refines crude oil into premium fuel in refineries across the globe. There is a constant need for its product, so production is continuous. In fact, its refineries in the United States process 1.5 million barrels of crude oil every day. These plants operate 24 hours a day, 365 days a year, in order to maintain cost effectiveness and match output to demand from consumers. Because of the large capacity of the operation, it is very expensive to shut down such a plant. Stopping production for just a few days can undermine a plant's profitability for an entire year. BP's facilities refine crude oil into a number of consumer products. Each barrel of oil contains 42 U.S. gallons, which is refined into 19.4 gallons of gasoline, 9.7 gallons of heating oil and diesel fuel, 4.3 gallons of jet fuel, and a host of other products. The first step in refining is separating the crude oil into these various components. Refineries have the flexibility to manufacture both gasoline and heating oil, but within the plant, each piece of equipment performs a very specific function. The process is automated, so operators spend much of their time monitoring and adjusting processes from a centralized control room. Chemical engineers determine the mix of products added during the conversion and treatment stages of the process. Others monitor such elements as the water used in the refinery to ensure that it's safe to return to the environment. The workers at the plant represent a wide range of specialized skills without much overlap. For a global petroleum producer like BP, continuous production is the most effective process choice. In many cases, though, consumers demand some degree of customization. In order to deliver a high volume of output and still offer some variety, manufacturers turn to a repetitive process called an assembly line. This is also referred to as mass production. Most consumer goods are mass-produced. Honda of America uses a repetitive process in their operating plant in Marysville, Ohio. At this plant, Honda produces a large number of only a few different models of their popular Civic line of cars. In fact, this plant alone produces an average of 20,000 cars every month, nearly 250,000 for each model year. The production process utilizes a connected workflow in which the product moves along a conveyor system past a series of workstations. At each station, parts are brought to the line to be added or assembled until the product is finished. In traditional assembly lines, workers complete the same task over and over. At Honda, workers are trained in a variety of tasks. They rotate workstations regularly to avoid fatigue and to maintain quality. Because each station is designed for a specific task, there is little need for flexible equipment. Workers interact with tools more than in a continuous process, but much of the work, such as welding, is performed through automation. Still, there's enough flexibility at each workstation to offer a variety of options on the model being produced. In repetitive processing, variety is created by combining individual modules. Engines, for example, are created separately from the main assembly line, allowing engines with different specifications to go into the same model. Body color and interior features and plug-in items, such as stereos and accessories, are examples of other modules that create variety within the steady, repetitive flow. While this process is so structured that each line produces only one type of product, the line that produces the Civic, for example, cannot build an Acura, Honda is seeking to change that. At its Ohio plant, for example, workers are trained on the next season's model of cars while they are still building the current model. Industrial engineers, meanwhile, are looking for ways to redesign the assembly line, building in so much flexibility that it could produce any model the company makes. In Aurora, Illinois, Caterpillar is already doing what Honda hopes to accomplish. This plant produces 24 different models of wheel loaders, compactors, excavators, and agricultural tractors, all in the same facility. Caterpillar produces 4 families of construction and agricultural equipment, but all in relatively low volumes. Because the volume of products they manufacture is lower than Honda's, and the variety of machine is greater, Caterpillar makes use of batch processing. This process creates products in small lots, or batches, in much smaller volume than Honda. Unlike repetitive processing, which depends on a connected workflow, batch processing involves a disconnected production line. Processing is intermittent, with workers coming to the machine rather than the product coming to them. A variety of products produced at relatively low volume with flexible equipment characterize a batch manufacturing process. Sometimes, products are created in batches as small as 1. When a highly specialized product is needed in a very low volume, based on an individual customer order, the process which matches the product is often referred to as a job shop. Eyeglasses are made using such a job shop process. Each pair is made to suit a specific customer's vision and head shape, so each pair must be created individually. At AED Vision, optician Jim Bracken has been making glasses for more than 20 years. He stocks lens blanks, which have already been ground to a specific prescription strength. After choosing the proper strength lens, Jim uses a bevel edger to custom cut the lens to the specific frames the customer has chosen. He then uses a hand edger to grind out any imperfections. The lenses are fitted by hand to the frames.
Hi, how are you?
Good, how are you?
Yeah, I got a beautiful pair of glasses for you.
All right, I can't wait to see them.
Finally, he fine-tunes the fit of the frame to the size and shape of the client's head. Although many of these same steps go into the creation of every set of glasses, fitting the lens to the frame and the frame to the customer is unique every time. Outside of the bevel edger, none of the equipment Jim uses is specific to his industry. Standard table salt in a pan on a hot plate serves as a heat source to soften plastic frames for bending. A nearby pan of water cools the frames. Standard flexible tools, such as a screwdriver and pliers, are used to fit metal frames. This is typical of many job shops, where a small set of general-purpose tools are used in a variety of ways. Because every product is custom-made, the equipment must be flexible enough to change with each new task. And since volume is small, the process can be geared to providing an exact, custom product. Highly skilled workers using general-purpose tools to produce a small volume of very specialized products is typical of the job shop production processes. The product process matrix illustrates the general rules of manufacturing or production processes. Finding and using the appropriate process is necessary to ensure quality and keep costs low enough to match the market demand and volume. It is unusual, however, that a product will fit so neatly into one process or another, and many products depend on several processes for their creation. These hybrid processes are becoming more and more common. The steel which goes into Honda's cars and Caterpillar's heavy equipment, for example, is created through a continuous process. If you order specialized stereo equipment for your car, it may be produced through batch processing. Although the eyeglasses created at AED are built in a job shop, the frames may have been created on an assembly line and the glass blank for the lenses through a continuous process. For many manufacturers, the goal is to create high-quality products with the efficiency of a continuous process while building in as much flexibility as possible in order to allow for more and more customization. At the same time, small volume producers search for methods to produce greater volume of specialized products at lower prices. In order to achieve this mass customization, manufacturers must understand the dynamic of the product process matrix.